Hey, this is my physics project for the end of the year. It's called Whatever Floats Your Boat. So my main research question was, how does Archimedes' principle help explain buoyancy and how ships stay afloat from buoyancy? I'll be exploring this question more. So some of my sub-questions were, what is Archimedes' principle, first of all? What is buoyancy? What type of material floats the best? What equation is needed to solve buoyancy problems? And what is the idea behind boat shapes and what allows them to float? So Archimedes' principle states that the weight of an object is equal to the amount of water that it displaced. Buoyancy is a vector, so that means that you have to find direction as well as the magnitude, and the SI unit of buoyancy is newtons. Buoyancy is affected by the density of the liquid and gravity, meaning that buoyancy is going to be greater the denser that the liquid is, and it's also going to be affected by gravity and how that acts on the object. However, buoyancy is not affected by the mass of the item. So the weight without the gravity doesn't really affect how buoyant the object is. So in this picture, it shows a rock being placed into a beaker, and then you can see that the water moves up after the rock is placed in. So if you were to take out that amount of water, it would weigh equal to the object. So for buoyancy, the symbol is B or FB, and then the buoyancy is the upward pressure caused by the fluid pushing back on the object. The deeper the object goes into the liquid, the higher the pressure. However, the buoyant force is not affected by the depth of the object. So, while the pressure may increase, the buoyant force will never increase. And the deeper a buoyant object goes, the more upward pressure is exerted on that object. This pressure eventually becomes stronger than the downward pressure, forcing the object to go back up. So this only really applies to a buoyant object. So in a pool, if you try and bring a tube down further and further, it becomes harder to bring it down. But if you throw a rock into a pool, it'll just go straight down because it's not very buoyant. And then an object has an equal buoyant force upwards to the weight of the fluid it displaces. Density affects buoyancy. Density is the mass of a determined volume. Two things can have the same size, but one can be denser than the other. The density of a liquid is the mass per unit of volume. Relative density is the density of one material when compared to another. So it could be wood compared to metal. Metal is much more denser than wood because the molecular construct of it. And then specific gravity is the density of an object when compared to water. Objects can float or sink based on density. If an object is denser than the water, it will sink. Conversely, if the object is less dense than water, it will float. So in this picture, it shows three objects: cork, wood, and metal. And then, as you can see, the cork floats a little bit more because it's not as dense as the other two objects. But the other two semi-float and then fully sink because they're denser than the water. So the equation for buoyancy is B equals PGV displaced. P is the density of the liquid, G is gravity, and V is the volume of the water that is displaced. Density is in units of kilograms per meters cubed, gravity is in meters per second squared, and volume is in meters cubed. So for a practice problem, density equals 900 kilograms per meters cubed, and then the volume equals 0.342 meters cubed. So for the buoyancy, you would do B equals 900 times 0.342 times 9.8 for gravity, and then that would give you about 3016.4, then that would be newtons. So how does buoyancy help explain how a boat floats? So large boats use hollow holes to stay afloat. These pockets of air make the boat less dense than the water, allowing for it to float. They displace enough water that weighs more than the entire boat. When the boat gets heavier and heavier, it sinks deeper and displaces more water. Some boats, like submarines, have tanks that fill with water. When filled, the sub sinks deeper and deeper into the water. This is because the open tank that was filled with air is getting denser and denser. If the tanks are empty, it is positively buoyant. If it is not sinking up or down, it is neutrally buoyant. If the tank is filled with water, it is negatively buoyant. So there are three types of buoyancy: positive, negative, and neutral. Upthrust is the idea that the boat is pushing on the water and that the water is pushing back. If the boat pushes too much, it will sink. And then boats are able to stay upright in the water because their center of gravity, or the engine, is very low in the water. So like normally on a kayak or canoe, if you stand up, it starts to shake and it might even tip over. But like in a really large boat, like a cruise ship or something, the engine is super low, which is generally the center of gravity, so then it doesn't flip. In this picture, there's a ship holding different amounts of cargo. So in the first one, it's not holding that much. It might even be empty. So it stays well above the surface of water. In picture 2, it has a lot more cargo and is sinking deeper. And as it holds more cargo, it sinks deeper, and the amount of surface area and water it displaces weighs more than the entire boat, keeping it afloat. In picture 3, it's barely staying afloat but still is happening, and then in 4 it weighs too much and is no longer buoyant. So in conclusion, the Archimedes Principle is a method that helps find the buoyancy of an object or density of a liquid. This concept can be used in the creation of watercraft. If the density of a boat is less than that of water, it will be able to float. Boats have large pockets of air, resulting in a greater surface area and lower density. And here's my bibliography.